pre-recorded. Book specifically says to use page 192 and anything else they talk about in the book.
Mhm.
Too many people are letting Google do the work for you. And then Google will pass the class and go on to have a great life, have little Google kids, the whole alphabet of kids. You've got to do the work. You must. So, all right. So I appreciate, no, listen. I appreciate, that was actually really creative. I really appreciate that creativity, but that's not what it's asking you to do. It's asking you to use the conversions that the book gave us.
Yeah, that's true. I did it in the pint. 1 pint equals 2 cups. 2 cups equals 16 ounce. And I changed from this 16 ounce to 8 ounce. This is just divided by 2. It's not too much work I need.
Wait. You said 2 cups is what?
2 cups equals 16 ounce.
Where do you get that from?
I think, I'm not sure if in my measuring cup or from this page, because I use only my measuring cup on this page.
No,
I didn't use this.
You have to take your measuring cup out of that equation.
Oh, okay. Yes.
Now on the page, it does say 8 ounces is 1 cup. So 2 cups is 16 ounces. That's fine. I don't see anything wrong with that. Right? So that's fine. Let me see. Let me look at your work here. Which problem are we looking at?
4, number 4.
Wait a minute. Where did all my markings go? This is weird. There we go. Okay. And my markings didn't show up. 8 ounces is, so the problem I had is yeah, there's nothing about 8 ounces being any number of milliliters. Yeah. Okay. So you can't, so that threw off your answer because it's not really true. That's an estimation you made from something that's not the book. Yeah. So I don't want to downplay any creativity. Like, that was really cool, using your measuring cup to look at it. That's a great thing to do in general, but that's not what the book needs.
Okay.
It's not what we need for this. We need to know how to use given conversions to go between things. Yeah.
Okay.
Yours is better though. I mean, other people are just going to Google and typing in something and getting the answer and doing it and not, like doing this. At least yours, you kind of used something real and not having some computer do all the work for you. So that I can appreciate. But okay, so more people have come in. A lot of issues with section 2.4. The biggest issue being, no, you cannot use Google to do the work for you. No. You must do as the book said. You must use the page 192 and any other conversions they might have used in the section. You are not allowed to go type into Google so many things and make it go to milliliters and pretend like you're doing work. No, that's not doing work. That isn't. You guys understand what I'm saying? So yes. Show your work, follow instructions. So the point of it, the reason you got to use page 192, because I always have somebody that's kind of like, well, I'm doing the work. I actually one semester. Good, sorry. Oh, sorry. Let me mute everybody. There we go. One semester, real quick, everybody go with me. One semester, I had a student, I was grading his homework, and a lot of his answers were straight out of the solution manual, right? So I told him, come to my office. I got to talk to you. So he came to my office and I said, hey man, these are all straight out of the solution manual. And he said, no, I did the work. I went to Google and I typed it in and I wrote down what I found. So he actually thought that typing the problem into Google and writing down what he found was work. And he was angry at me. He did not understand. So And the best part of the story was he tried to slam my door, and it was one of those with the little, it goes, sorry. And he goes, anyway, sorry. I'm feeling a little ranty this morning. I'm sorry because, and I don't think most of you guys did this maliciously or anything, but it specifically says use page 192 for section 2 homework. If you don't, you're not really learning what you're supposed to learn from this section, which is how do you convert between units? The answer is not Google, right? You need to learn it. Okay. So it's a question of nowadays, Google can do everything, but humans still need some of that in their own heads, right? The more you have in your own head, the more you can do. Looking everything up on Google. Anyway, I'm sorry. I'll stop. Enough rant. Does anyone have any questions from any homework or?
Yes, but Professor, can I ask you about number 8
Yeah.
homework?
In section 2.4?
Yes.
Yes, please.
Yes, please. All right, let's see. Yeah, number 8's neat. Yeah, good. This is the big one. I was talking about this in office hours, and I said I was definitely going to talk about this during class because a lot of people got this one wrong. Here's the thing. Now, just go with me. On number 6, where would you start on number 6? Like, what would you write down first? On number 6. Anybody?
203 divided by.
No. So let me catch up to 203. You're not dividing. Yeah, 203 millimeters per day. You're going to write that down. You always write down what it is you're starting with, and then you're eventually going to go to what they want you to end up in, right? So I am trying to take millimeters per day and change it into inches per hour. Does everybody understand that so far?
Yes.
You write down what you're starting with, and in the middle is going to be a bunch of conversion factors, right? So you're going to have to convert between millimeters and inches and so forth. Okay. Number 8. Number 8 says, how long would it take the glacier to move the length of a football field? So can somebody tell me, what am I trying to convert from to? From that first sentence, what am I trying to convert from to? Where do I want to end up? What my answer has to be what physically? Anybody?
The hours.
I want my answer to be in hours. And what is it that I know I'm trying to convert to time? What am I trying to convert to time? I want to know how much time it takes for what to happen.
The 100 yards.
Yes. So you write 100 yards down first. You're trying to convert yards to hours. Now, can you do that in general? If I ask you, just ask somebody randomly, can you convert 100 yards to hours? They're going to look at me like, what the hell is your problem? But it works here because we're talking about a glacier moving. So do I have a conversion from length to time? Yes, your answer to number 6, right? Your answer to number 6 is inches to hours. So you should get on number 6, I'll go ahead and give this to you, 0.33 inches per hour. So do you see how that's a connection? I really want you guys to see. Well, 100 yards is where I start. That's how far I want the glacier to move. This goes from length to time, and I do want to end up in time. I can't use this conversion unless my distance is in what units? When can I use this conversion if I have a distance in what units?
You need it in yards.
No, it is in yards. I can't use this conversion unless it's in inches because that's what the conversion has. It has inches, right?
Inches per hour.
So I start with 100 yards. So I already know what my path needs to be. My path needs to be yards to inches to hours. Yards to inches is something we know. Inches to hours is because of the glacier moving. It's the 0.33 inches per hour. That's what converts that. So a lot of people were starting here or starting somewhere strange. You start with what you know. You know you want it to go 100 yards. That's what you write down first. Right? So how would I go from yards to inches? You might have to take a step.
Yard to feet.
Yeah,
feet to
yards.
inch.
So I can go yards to feet to inches. Those are all everyday conversions. And then the last one is not an everyday conversion. It's because I'm talking about a glacier moving. I can go from inches to hours. I normally can't go from inches to hours. How long is it going to take you? About 3 inches. What? That's about 6 hours. What the hell are you talking about? Does that help at all? So a lot of people got number 8 incorrect, but you start at 100 yards. How do I convert that? Now, so I've identified my first step to feet. How do I convert that to feet? Where do I put yards? Top or bottom?
Bottom right.
Bottom, I like it. Yards to feet. And then I throw in there 1 yard is 3 feet, and you keep going. Now I want feet to inches. So feet to inches, 12 inches in a foot, and you keep going. Now I want inches to hours, and I've got this bad boy. All right, that's as far as I'm going to go. I'm basically done the problem for you, but the big problem people were making was they weren't starting with 100 yards. That's what I'm trying to convert. I want to convert 100 yards into a time for this glacier to move. Okay. Is everybody, you guys okay out there? Anybody? There we go. There we go. I see more people. That makes me feel better. Makes me feel less insane. All right, that's all I'm going to get. Okay. How's everybody else? Any other questions, or was that not good enough? Are you guys okay with number 8 now?
Excuse me, Professor. I didn't understand. What do you want to do about the inches to hours?
Again,
Can you finish it?
well, I really don't want to because it's your work, but I've given you the answer to number 6.
Yeah.
Right? I've given you that answer. And what is that a conversion between? Isn't that a conversion between inches?
Yeah.
Hours? So 0.33 inches is 1 hour. Can't you figure out where to put inches and hours here?
Yeah. Thank
Okay,
you.
good. So you can finish it up. Yeah.
Yeah, but how you find this answer? Sorry, because I have a different
Wait.
result.
For what? For number 6?
Yes.
All right. Since I gave you the answer to number 6, we'll go ahead and do that one together. So somebody, let me see. I got to move this up. So I'm going to erase everything. You guys ready? Everything's going away. Here it goes. Gone. Okay. So it tells me, shoot, hold on. God, I can't wait till I have a room and a whiteboard and people with the room with me and everything. Well, I already did number 8. So I'm done with number 8. So it gives me 203 millimeters per day. That's where I start. That's what I know. Now, where am I going to go? I want to go to inches per hour. So some people changed millimeters to inches and stopped. But that means what? Did you get inches per hour then? No. It's in, do you guys understand what I'm saying? So a few people changed millimeters to inches, but never changed days to hours. So you didn't answer the question. It wants inches per hour. So I've got to change the millimeters, and I've got to change the days. All right. So let's do the millimeters first. Where am I going to put millimeters? Let me erase some of this stuff real quick. Where do I put millimeters? Top or bottom?
Other.
Bottom. So it's across from there, so it will cancel. And I want to go millimeters to inches. 25.4 of these is one of those. Bam, bam. So now I'm inches per day, right? So what do I want to get rid of now? What do I not want? I want inches per hour. So what do I want to get rid of? The millimeters is dead. What's still alive that I don't want alive?
They have to be over.
Hour.
It has to be hours. So what do I want to kill? I think you said day instead of they. Okay, day, right? I want to kill days. So where am I going to put days? Top or bottom?
Top.
Yep, top.
So a lot of you guys just do not believe me when I say this grid helps you. Some of you guys multiplied when you should have divided and the other way around. If you just set up the grid, it tells you when to do what. Days to hours. So what do I put next to days? What do I put next to hours?
1 day, 24 hours.
Holy shit. Yeah, 1 day, 24
24
hours.
hours.
So then, and then I'm going to get, now let's see, days dies. So what am I going to be left in? Inches per hour. Sweet. That's what they want. Do you see that? I know when I'm done with my grid, when I've got the units matching what they want. So what am I going to put in my calculator? 203. What do I put in my calculator?
Divided by 25.4. Divided by 24.
Good. Beautiful. And that should give you 0.333, but you can round it to, I think it says 2 decimal places at the beginning of the homework, if I remember correctly. Is that all right? So you have got to trust me. A lot of you guys are getting things wrong because you don't, for some reason, believe in this. And you just take guesses and your guesses are wrong. You're multiplying when you should be dividing or the other thing around. Okay. You've got to help. You've got to have some faith in this. Even I use this. I pretty much know when to divide and multiply, but I still do this just to visually make sure I'm doing the right thing because it's so easy in your brain just to multiply things together. And you're like, oh, I should have divided. Oh, crap. Right? All right, maybe. It is kind of nice to see the units kind of doing what they're supposed to do. It's nice to have a visual confirmation that it's happening the way it's supposed to be. That's what the grid does for us. All right. Believe in grid. Grid here to help. I am grid. All right, that's enough. Any other questions from homework?
Excuse me, can you check number 5, please?
Check it. Let me see. I'm going to clear all this away. Here it goes. Clear. All right. So there's number 5. What do you mean? What's the question?
My question is, when I divided 98,000 to 2 feet, you said, what is that? I want to get the miles. That's why I did it.
Okay. So your question is more specific. Yours specifically, let me see. Where are you? There you are. Oh, yeah. Yeah, you rounded too much. That's all.
Oh, okay, understand.
Okay.
Thank you.
Sure. Yeah, technically on that problem, you shouldn't round it all. If you put the whole grid down, you don't have to round anything because you'll just put everything in the calculator until you get to the end. Then you don't have to round anything. How's everybody else? Anybody else with questions? So on your homework, if you see me saying this, yeah, do that. You cannot get conversions from Google. No. the homework says specifically to use page 192 and anything else that came up in the section. That's it. And there's a reason for that. The point of this chapter is, can you convert between things with a given set of conversions? You can go to Google and convert anything straight into anything else. That does not help you learn the lesson. So that's not going to fly. Okay. I have no problem with you checking your answer in Google. It's probably not going to be exactly the same because we're rounding some of our conversions, but it should be close. Some of you guys, a couple of you guys wrote the right work down and then you wrote the answer that came from Google. I don't know. Just stop doing that. Just stop. Stop. Okay. Anything else, guys? Anything else from homework? Any other questions? All right. So I don't know how much you've had a chance to do. I don't think too many of you guys have had a chance to do section 2.5 yet. The main thing with 2.5, to be honest, there's really not a lot of word problem stuff in here. It's mostly estimation is the name of the game. Yeah. So we'll see how you do. Anybody out there ever been a waiter or a waitress? Anybody?
Yes.
Nobody? I was going to say, how did you guys all manage to escape that? we all have to put our time in, don't we? Yeah. So, or has anybody ever eaten at a place called a restaurant? And you're supposed to leave a tip, right? If you were ever a waiter or a waitress and you're like, no, don't try to do math in your head because you don't know how to do it. And you're going to give me a crappy ass tip. So sometimes it says in the receipt what the tip should be and so forth, right? Do you know how to estimate the amount of tip to leave for any kind of meal for any? If you were a waiter or waitress before, did you have a way to kind of estimate what that's supposed to be? Or is everybody worked in the time of receipts all have the tips on them? There used to be a time when that wasn't true.
So I used to be happy with just a 10% tip if you tipped at all.
Yeah, it's unfortunately true. I have several friends who were waiters and waitresses for a long time. I actually never was. I did my time in McDonald's way back when. Yeah, and that was, yeah, no tips there, but at least we got paid the full amount. It's crazy. So let me show you one example of estimating a tip, because that comes from this section. And then we're going to actually kind of start looking at the next section because we're all crazy. Okay. So what's kind of the standard tip percentage? Does anyone know? It's really not 10%, is it? What's kind of the standard tip percentage?
18.
I like 18.
Was 18?
All right, so let's do this.
20.
Say again, 20?
20. Yeah.
Ooh, I like it. Even better. So let's say, let's see, are these good? Let's say I got a meal with some friends and it came out to be $86.42. Yeah, it's true, but thanks, Guillermo, but I was asking, like, what's a percentage of tip that you normally leave? So let's say we're going to leave 18% tip. So how can I estimate it's the amount? Nobody brought their calculator to the restaurant. I'm not surprised. We all don't have our phone. All of us left our phone somewhere else because the phone didn't used to have a calculator on it.
Could you do some rounding?
Say again?
Could you do some rounding?
Yeah,
to
let's do some
self-estimate?
rounding. Yeah. So how would we, so what is it we have to officially do? If I had a calculator, what would I do to figure out exactly the tip?
86.42 times 0.18.
Good. 18% of 86.42. So you can write them either way, you're right. Okay. So how do I estimate this? What would I do to estimate how much it's going to be? Why are, so these numbers are ugly. Can we round them a little bit to make them nicer?
20% of 90.
20.
I don't know. That still seems kind of ugly,
So
right?
85, yeah.
No, this is
$85.
beautiful. What are you talking about? 20% of 90.
Okay.
What's wrong with that?
Yeah.
So here's a cool way to do this. What's 10% of 90? That should be easy. What's 10% of 90? What's 10% of
$9.
anything? Sorry,
Nine.
$9.
Yes.
$9.
I love it. 10% of anything is that thing divided by 10. Why does that make sense? What's 10%? Isn't 10% 10 over 100? Which is 1/10. That's why 10% of anything is that thing divided by 10. So what's 10% of 90? 9.
$9.
So what's 20% of 90?
18.
18. Is that a little high or a little low?
A
Or
little
what
little
high over
A
what
little
you're
high.
trying to
Yeah,
say.
it's a little high because I rounded that up and I rounded that up. Right.
Mhm.
Okay.
For me, I just put 20%, but I put 85 instead 90. In this case.
Oh, I
maybe
see. I
match.
see. Sure. You could have, so I like what you're doing. If you round one piece up, you
Yeah.
technically should round the other piece down so that overall
Yes.
it comes out closer to the
Closer.
right amount.
Uh-huh.
Now watch, this is still not that bad. What's 10% of 8.85? That's 8.5. Is that cool? Divide by 10?
Yeah.
So 20% would just be
70.
twice that. Yeah, it would be
17.
17. So $18, $17, and it's all the same. I like it. So I like the point you just made. This book doesn't make a big deal out of this. If anybody takes 120 after this course, there is some more estimation in there, but if you round one piece up, you really should round the other piece of a multiplication problem down so that they kind of average each other out. Does that? But this one, if I do this, I know that's too high. Right? Okay, maybe. So that's the nice thing about percentages. Now watch this. I want to show you. I'm going to resolve this. One more thing with percentages. So like if I had to do 12% of 40, well, what's 10% of 40?
4.
4. So what's 1% of 40? You can do it. You can do it.
40 cents.
Good. 0.4, right? Divided by 10 again. So what's 2% of 40? If 1% is 0.4, 2% is?
20 cents.
Say again?
0.8.
20.
0.8, right? Come on.
Yes.
If 1% is 0.4, 2% is twice. So it's 0.8.
8.
So what would 12% be then? I just add these. Do you guys see what I'm doing? 10% and 2% would make 12%. So what's 12% then? 4 plus 0.8 is $4.80.
Wow.
You can kind of put things together based on 10% and 1% because it's relatively easy to find 10% and 1% of anything. It's just moving the decimal place. And then I can build whatever I want to. Maybe?
Yes, easier.
Yeah, thank you. Right? Okay. So that's kind of neat. Percentages are much neater than you might think. Now, all right, I think I said this is the last one, but no, I'm going to do one more. You sometimes you'll have a problem like this. I want to find 24% of 81. This is almost what? Which would be easy. Come on, you can do it. What's the easy? 24% kind of sucks. Well, what's the nice percentage that's easy to do that's close to 24?
25.
25, because that would just be a quarter of something. So 25. So I'm going to say it's approximately 25% of 80. Well, what's 1/4 of 80? Right? I made that go up. I made that go down.
It's gonna be 20.
20.
What?
Yeah.
Now, can somebody do this in their calculator? What's the actual amount? What's 0.24 times 81? So 20.25, 0.01, 0.81, 19.44. No, I don't know what that is. Is it 19.44? Neat. Good job, Jeff. So, I mean, we got 20 for our estimation. It's actually 19.44. That's pretty good. Okay, maybe. So estimation means rounding the parts of the problem to a point where you can do it in your head. You should not need to use a calculator after you've rounded things. That's the whole point. You can check, you can actually do the real problem and see how close you got, make sure that it makes sense, right? Okay, maybe. All right. Okay, all right. So a lot of estimation in that section, what was it? 2.5? Yeah, 2.5. A lot of estimation in section 2.5. Now, we're gonna sort of get into section 2.6 a little bit. All right. Let me remind myself what I wanted to do here. Oh yeah. Yeah. Okay. So let me ask you this. Let me ask you a nice little question to get us started. So 2.4 was all about conversions. 2.5 is all about estimations, right? 2.6 is all about related to this. I'm not even going to tell you what it is. Let's do a problem. Let's say that last year, well, let me just do this. All right. Yeah, that's fine. Last year, my company made $100,000. You can do it, Jeff. There you go, buddy. This year, that increased by $2,000. What percent was the increase? By what percent did my profit increase? How would I figure that out?
2%.
How do you figure that out? What do you do?
This is 2 of 100.
Sorry?
This is 2% of 100.
Well, you're kind of guessing and checking. What do I do with the numbers I'm given to get to 2%? How do you figure out the percentage of anything? Don't you divide the part by the whole, right?
Yeah.
So in this case, I'm dividing the change. How much did it change by? Divided by the original. Does that make sense? So it changed by $2,000 and it started at $100,000. Let me stop for a minute. One thing I really, really want you guys to get is how do you find a percentage? Do you notice that's been in a lot of different sections this semester? Percentages? Because it's crazy important. They're every freaking where, percentages. How do you find them? You divide a part divided by the whole. It's the part out of the whole. Whoa. So in this case, it's change divided by original if you want to make something more specific. Yeah. So that does come out to be 0.02, which is 2%. I like it. Okay, no big deal, right? Now, I'm gonna erase this. I'm gonna let you guys try this next problem on your own. So last year, $98,000. This year, $90,000. What was the percent decrease? Let's see, be careful now. There's a little something different here. There's something I did not do for you that I did in the previous problem. Don't say anything out loud. Just try to do it. All right, who thinks they have the answer?
$1.08.
Whoa, no. Let's see. What did you do to get 1.08?
Is it 0.09?
Oh, I see what you did.
A 0.09.
0.09, not quite.
Oh yeah, that's way too small. Never mind.
No, it's almost right. I'm not sure how you got 9 though.
Is it 0.088?
No,
Oh, never mind. Okay.
this is freaking me out. Now, what is it that I did? Now listen, you guys. There's 22 people here right now. Everybody with me? 22 people here. What's the first thing you have to know to figure out the percentage of people in here that are women? What would I have to know before I could figure that out?
How many women are here?
How many women? So if I want to know the percent decrease, not percent women, but I want to know percent decrease, what's the first thing I have to know?
The women.
Oh, women. No, nothing about women.
Sorry.
Nothing about women. If I want to know the percent decrease,
The
So
difference. The difference.
I got to know the
between-
decrease, right? If I want to know the percent women, I got to know how many women. If I want to know the percent decrease, I have to know how much the decrease was. Well, how much was the decrease? How much did it go down by?
8,000.
8,000.
Mhm.
What was the original?
98,000.
So divide those two.
That's what I did wrong.
8,000 out of the original amount.
Oh. 8%?
That's better. Maybe round it to 1 decimal place.
8.1%?
8.2.
2.
So you get 0.0816 blah, 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 which is about 8.2%. I really want this to make nothing but sense. You always have to base it on the original. Because if I said last year we made $98,000, that then decreased by, no, stay with me. 98,000 last year, that decreased by 8.2% to get to 90,000. Let me say that again. Last year was $98,000. That amount decreased by 8.2% to get to 90,000. What am I taking 8.2% of? $98,000 last year. That amount decreased by 8.2%, got me to 90,000. What am I taking 8.2% of?
98,000.
98,000. I'm always taking the percentage of where I used to be.
From the original, yes.
Original. That's why to get the percentage, if I don't know the percentage was, it's got to be based on where it started. Okay, I like it. Maybe I like it. Kick ass. Okay, so I'm gonna erase all this. Now here comes something interesting, a little side note, sort of. Let's say last year, 4,512 people showed up to some concert or something. I don't know. You can do it, Jeff. Up. This year, 1,987 people showed up. What was the percent change? Oh, maybe I should do this.
56%.
Let me see, let me catch up to you. Divided by, sounds about right. Yeah. So, very first step is to do what?
Well, subtract
Yeah.
4,512 to 1987.
I like it. Figure out what the change was. In this case, it was a decrease, right? But in general, we could just call it how much did it change by? So 4,512 minus, Jeff, you could do it, buddy. 1987, that gives you, oh, I like it. I wish I could take credit for this. 25. So I really stay with, so I want to know the percent change. So I first figure out the change, and then I'm going to divide that by what?
By the original.
By the original. And that does give you 0.5596, blah, blah, blah. So I can approximate that to be 56%. I like it. Now, here's something interesting. Any questions on that? This is the main thing we've done so far. So it could be an increase, it could be a decrease. In this case, you would say 56% decrease, right? Obviously, because it went down. What if instead, so second problem, what if last year was when there was 1,987, and this year there was 4,512? What's the percent change?
56% increase.
No. Nope. Wrong. Sorry. I kind of set you up for that. I did. Why is that wrong? Do the steps. Do the steps. What are the steps? How much did it change by? We already know that. We know it changed by 25, right? But what do you divide by? What do you divide by? Always.
By the original,
Original. What was the original amount?
it's 1987.
1987. There we go. So what's that? Don't freak out. What do you get? You can do it. Don't freak out. It's fine. It's okay. The answer's fine.
It's 1.27.
So about 127%. You guys with me?
No, at all.
Why not?
No,
What's the
it's confusing because why we didn't do same last one?
No,
We
no, no, no,
subtract
we did
the
exactly,
last year
listen,
with the
listen,
this year.
listen. We did exactly the same thing we did last time. What did we do last time? We divided the change by the original.
Yes.
Here, what did we do? We divided by the change by the original. We did the exact same thing. What was the original amount in this problem?
But the change is different now.
No, why?
It's 1987 minus
Oh,
4512.
no, it's 4512 minus, how much did it change by? So here, technically, this would actually be the other way around if you wanted to be technical. I really want you guys to be with me on this. It's the end minus the beginning, to be honest, but that doesn't matter. That's kind of a silly, stay with me now. Didn't this go down by 2525? Didn't it go down by 2525?
Yes.
So technically this should be negative,
Mhm.
but that doesn't matter. Do I need the negative sign to tell me it was a decrease? Don't I already know it was a freaking decrease, right?
But it's not the second one increase instead decrease.
Then it's
Because the opposite.
4512 minus 1987 is still 2525, right? The negative would just mean decrease instead of increase. That's all. But we already know it decreased. That's why that's unnecessary. I don't need that information. How much did this change by? 2525 down. How much did this change by? 2525 up. So isn't the change 2525?
Yes.
That number doesn't change.
Mhm.
Divided by the original.
Okay.
Okay. So technically this should be a negative 56%, but I just say 56% decrease. That means negative. That means down. Okay. And maybe, hopefully. The 2525 doesn't change, right? That's still a 2525. Okay, maybe. So why did this happen? Stay with me. Would you not say that this more than doubled? Didn't this more than double? What would double this be? Wouldn't double this be under 4,000? You guys with me? If I double this, that's almost 2,000. So doubling would be almost 4,000. Well, this is more than double, isn't it?
Yes.
To double means to add 100% of it to itself. Right? So if I have 5, what's 100% of 5? 5. If I add 100% of 5 to 5, I get 10. So a 100% increase would mean it doubled. We more than doubled, correct? So
Yes.
that's why this makes sense. It's a little over 100% because we more than doubled. So to double something, you have to increase it by 100%. Is anyone not okay with that statement? I could be insane. I could have just went temporarily insane. I could be totally wrong. So if you think I'm wrong, let me know. I could be. I'm just, you never know. Does that sound incorrect to anybody? Because a lot of people think you do 200%, but no. If I add 200% to something, that's tripling it. Maybe. If I add 100% of something to itself, that would be doubling it, right? Okay. I like it. So that's why this answer, it's okay for something to be more than 100%, because that would mean it's just more than doubling. How's everybody doing? Somebody unmuted for a second. You guys all good? Okay. All right. So this is a beautiful example of you have to be careful about what the original was so that you divide by the correct thing. All right. So let's do this. Let's go in the book. Let's see what the book has for us. Make sure I don't miss anything. Uh-oh. Come here. Oh my God, so much technology. All right, let's see. Where are you, book? Here you are. Where'd the class go? There you are. Okay, let's see. What do we got here? So here they do make a big deal of subtracting the correct amounts, but this is kind of silly. All right, oops, shoot. Einstein, stop doing stuff to me. Both of these to me, well, here's the change, right? You have to first calculate how much it changes by. And then you divide the change by the original. That's exactly what I told you guys. I like it. So good. So far, the book is getting it correct. I like it. Oh, yeah. So what we use instead of percent is we call it relative, but we know it means percent. Relative changes are written often as percentages. Okay, so in the book, you're going to see the phrase relative change. We know that means percent change. So can you guys do number one? The numbers are just a little bit more disgusting, but not too bad. Right as a fraction. Why would you do that shit? Don't do that. Just give me the percent. So the first thing you gotta do is figure out what the change was. So what was the change in this problem? How much did it change by?
10.
10 bucks. I like it. Right, 10 bucks. That's how much that I'm off by. They gypped me 10 bucks. So how would I figure out the percent change? What am I going to divide?
$5 million.
Sorry?
10
Yeah, the change
Yeah.
divided by
original
Original.
amount.
what's the
5
original amount?
5 million.
5 million. I
million.
like it. I like it. And then, you know, whatever the hell that is. Let's see. 2 over 10 million would be, let's see, 0.02. I think it's 0.0002%. Oh shit, my poor battery's almost dead on my calculator. I'm sorry, calculator. Yeah. So you get 0.00002, which is 0.00002%. Just move the decimal once, twice. You guys okay out there, everybody?
Yes.
All right, spokesperson has spoken.
Yeah, this is yeah, it's kind of right.
All right. There's a, you know, so part of this is going to seem very simple, probably, but there's a lot of misunderstanding about percentages. It's insane. And the biggest mistake people make is not understanding that 10% does not equal 10%, for example. It depends on 10% of what, right? So the base amount, the original amount is what really, really, really matters, which is like the problem we did up here that shows you it went from 56% to 127% based on what was my original amount. So it's all about what was the original. All right, let me clear this away. All right, let's see if they have anything more interesting here. Blah, blah, blah. Okay. Your instructor tells you that you're going to get an additional 2 points. Oh. If I'm going to give you an additional 2 points, when would that be amazing news? Can you think of a situation where that would be like, whoa? Anybody? Like the way I grade, would an additional 2 points be like, whoa?
Yes, extra credit on the quiz or the test. It's wow.
Let me try this again. Have you guys ever taken a quiz and the instructor graded it out of like 15 points or something? Or out of 20? Have you
Yes.
guys ever gotten a quiz and it came back and it said 14 out of 20 or something like that?
Yes.
Why would 2 points being given back in that situation mean much more than if I gave you 2 points? Because I grade out everything out of 100 like a normal person does, right?
It would change your percentage.
Yeah, so if it was a 20-point quiz, how much does that change your overall grade? So in a 20-point quiz, I'm asking you, what does 2 points mean? 2 out of 20 is what?
10%.
10%. It would increase your grade by 10%, a full grade change, right? So out of a 100-point quiz, obviously, you guys, how much would 2 points change?
0.02%.
0.0, well, not 0.02%, 2% or 0.02.
Oh,
So if you got a 91, it would make it go to a 93, right? Or if you got a 52, you would go up to a 54. Thanks, Jeff. But this one, if you got a 52, you would go up to a 62. Which, you know, is still not great, but it's a hell of a lot better than just going up to 54. Are you guys all with me? This problem, I love it. Because that is the base amount for one type of quiz, and that's the base amount for a different kind of quiz. And it's all about the base. Sure, Jeff. Why not say that? No, is that too old of a reference? All about the base? No, okay, I'll stop. Let me clear this away. I won't start singing, thank God. Actually, let me see if I can do this problem down here. What in the world? Nah, screw that. Let's do this next page. Let's see. Yeah. So Apple's profit in 2016 was 14.4% lower than it was in 2015. So can you write something using this terminology? Can you describe that happening using this terminology? This is kind of a weird question, I know. What part of this, can you guys do this for me? What part of this problem is the relative change or the percent change? What part is that?
14.4%.
Yeah.
14.4%. Sorry.
You got it. You're okay.
My mouth is very dry.
I understand. So I could say the percent change in Apple's profit from, holy macaroni, 2015 to 2016 was 14.4%. Not a big deal, right? This is the percent change. So that's exactly the percent change in whatever was this percentage. All right, not a big deal. I could even be more specific and say the percent, what would it be? Decrease or increase?
decrease.
Yes, percent decrease. I could be more specific. So change is just sort of a general catch-all. It could be up or down. Decrease is specifically saying the change was negative. It was a down change. All right. All right, no big deal there, I don't think. Let me ask you this. I don't think I've asked you this before. Let's say, all right, let me see. Do I have some blank space somewhere? Yeah, let me get some blank space. Let's just scroll past all, there we go. Look at all that. Yeah. I don't think I've done this with you guys. I can't remember now. Let's say I make $10 an hour, right? I might have done this with you guys. Tell me if this sounds familiar. I get a 10% cut for no reason. I notice on my paycheck that I was paid 10% less. Are you guys with me? So I go to the payroll office and I'm like, what the shit, right? And they say, oh, I'm sorry. We'll increase your pay by 10%. Am I happy? Am I okay with that? Are you okay with that? Would you be like, oh, great. Thanks, guys. Are you guys with me? So let me see. Let's do this in 2 steps. How much did I get paid per hour if there was a 10% cut?
$9.
$9.
Yeah. So I'm getting paid $9 now. So when they increase my pay by 10%, they're doing 10% of 9.
Yes.
Which is 0.9. So now I'm making $9.90 an hour.
Yes.
I'm still pissed. I'm losing a dime every hour. That adds up.
Mhm.
No. So again, this is just another illustration that 10% does not equal 10%. It depends on the amount. I think we've done problems. I'm almost certain I've given you this example before, but because we've talked about stuff like if they have a 20% sale and then they say an extra 10% off of that, is that 30% decrease? Is that a 30% sale?
No.
Why not? Isn't 20 plus 10, 30?
It is, but it would be 10% off of the already done 20%.
Beautiful. So let's figure this out. All right, so let's do an example. Let's do a specific problem. Let's say something cost $200 and they have a 20% off sale. And then they're like, oh, we'll take an additional 10% off. So the salesperson, not necessarily trying to deceive me, but they say, oh, so it's like 30% off. They might not be trying to deceive me, but sometimes they are. So let's see how much this really is. Stay with me. This is a neat problem. You guys can do this. So after the 20% off sale, how much will it cost? How would I figure that out? How would you figure out after the 20% off, how much will it cost now?
160.
How'd you get that?
I cut off the 10% of from 200. It's got $20.
20. So
Yeah.
then 20% would have to be
$40.
$40. So 200 minus 40 is 160. I love it. That's awesome. Now they take an additional 10% off. So that would be 10% of 160 is how much? That's nice. Just divide by 10.
It's gonna be 144.
Yeah, so 160 minus 16 is 144. So again, I really want everybody with me. I'm figuring out how much it will change by and then applying the change. How much will it change by and then applying the change. Now, how much total did it change by? What was the original amount?
200.
200.
So 200. And what was the end price?
144.
So it changed by $56. Is everybody with me?
Yes.
So what was the percent change then? The overall percent change? It'll be the change
Yes.
divided by
200.
200.
the original. So what's 56 divided by 200? Bang.
28%. Yeah.
20%. So it's not 30%, is it?
No.
All right. And then if you apply more and more percent discounts, then, it's not going to be. The really big one would be if you do a 50% off sale and then another 50% off on top of that. And they're like, it's basically free. No. Okay. Maybe. There's a lot of good shit here. A lot of good mathematics. Whatever, Jeff. All right, let me clear all that away. Okay, so let's do this. There's quite a bit left to go. It's basically all built on this idea of relative change, but I still want to do some more of these examples with you. But I think let's see. Yeah, let's call it a day for now, and then we'll get into the other examples tomorrow. So again, all the quizzes are graded. I've graded, I think I graded all the 2-4 stuff that was turned in. I think so. So take a look at that. Let me know if you have any questions. Otherwise, you're free to go. You guys okay? Yes?
Yeah.
Thank you.
Thank you.
Hey, Professor, I wanted to ask this just before I head out. On the homework, I might be doing this wrong every time, and that would be really embarrassing. But when I get a correct on my homework, is that half credit? Or
Yes.
that's half?
Yes.
Okay. What is a full credit? Just like,
It would say okay. It would say complete. It would have a check mark instead of an X.
okay, thank you.
You're welcome. Everybody else okay? All right. I'm gonna.
Did you get my recommendation from ARC?
Hold on. It doesn't sound familiar. I don't think I did. Let me double check.
Get it. Go get it. All you gotta do is drop her name.
Oh, here it is.
And I explained to them that I'm having problems, so they're gonna help me get in the tutor center. So I should be in a tutor center soon, and then I'll be able to turn in mostly all my work.
All right. So let me. Yeah, they sent it to me. I'm gonna go ahead and sign it and send it back. So I got it. So you'll be ready for the next thing and for the midterm. Yeah.
Yeah. Okay.
Okay.
All right.
When you come through with your shit.
Uh-oh. All right, guys. Anybody else? I'm gonna head out. Everybody, you guys are all really here. I know. All right.